All right, so we're going to look at the domain and the range of a exponential function. So just the definition again of domain. Remember, domain are the possible x values where a function exists left to right. So where does the function exist left to right? The possible x values. So for any typical exponential function that is unrestricted, meaning from left to right, it has no limitations, it has no restrictions, then we know that x will always be an element of real numbers if the function is unrestricted left to right. Of course, if there are restrictions, meaning there's an open dot at the end point at the left, and then there's the open dot at the end point at the right of the function, then obviously we'll look at it within that interval and write the domain accordingly. But if the function is unrestricted, then x is an element of real numbers, meaning for all possible x values of x real numbers, we would basically say that is the domain. Okay, then what about range? Range, on the other hand, is the possible y values where the function exists. And remember, the function exists for your y values from the bottom up. So we're starting from the bottom to the top. Okay, so if a is less than 0, remember, when a is less than 0, that means the function is found below the asymptote. So that means that the range the range of the function, the y possible values, the function will only be possible below the asymptote. So that is why we say y is less than q. Okay, remember q, okay, there'll be a specific q value whether that be a horizontal asymptote, that's y is equal to q. So we would write, go ahead, y is equal to 2, sorry, then we would say y is less than 2. If the asymptote that's given is y is equal to -2 and the function has a value that is less than 0, then basically we know that our function, we anticipate to find that function below the asymptote. So y will be less than that -2, which is the equation of the horizontal asymptote. Okay, so whenever the function is found below the asymptote, then we write the range as y is less than that value of the asymptote. If the function is above the asymptote, remember, when a is greater than 0, then it means that the function is above the asymptote, and therefore our range will be y is greater than that q value, or that value of q, which is the horizontal asymptote. And remember, we don't include the q value. Why? Because the function, it does not exist on the line. So that's why we say y is greater than q, not y is greater or equal. We say y greater than q alone. So that hopefully that helps establish our understanding of domain and range. So in a function like this, you can see that the function is found below the asymptote, so y would be less than that asymptote, whatever the value of the asymptote is there. Again, in this function, you can see the function is found below the asymptote, so y would be less than for our range. Okay, but in both cases, since the functions left and right are unrestricted, for the domain, we would say x is an element of real numbers for both of these functions. Let's look at this function. Okay, just gonna put a bit of a spanner in the works. Let's say that there was a shaded dot here, and let's say this was open, right? And we knew the specific x values. Let's say this was 2, and let's just say this was -5. So if we were to write the domain of this function, we would look at the specific x values, because this is a restricted function. It's not an unrestricted function. It exists from this negative x value to this positive x value. So therefore we would write the domain as x being greater than -5 but less than +2. Okay, that would be the value of the domain. Or we'd say x is an element of, or remember, we write the equal sign here because it is shaded, but because it's open here, it means that the 2 is not included. Or we could say x is an element of -5 square brackets to 2 open brackets. So hopefully you guys get the point that if the function is unrestricted and there are specific the function is restricted, meaning it's restricted in that it starts, there's an endpoint at the left and there's an endpoint at the right, and basically that would mean that we write the domain in accordance to those restrictions. But like I said, with arrows on either end, it means that the function is unrestricted, and therefore with no restriction from left to right, we'd say x is an element. Here we'd say the domain is x, an element of real numbers. I hope that makes sense. And likewise here would say x is an element of real numbers for the domain. But here, because of the restrictions, endpoints here, shaded dot open, we would write our domain as x is an element, close bracket, -5, open to 2, not included. Okay, that's domain. Domain here would also be unrestricted, x is an element of real numbers, but look at these functions, both of them, they are found below the asymptote. If we write our range, y would be less than the value of the asymptote. Here as well, y would be less than the value of the asymptote, because in all these cases, a is less than 0, meaning that the function is found below the asymptote. But look at these functions. If we were to write the range of these functions, possible y values where the function exists, see a is greater than 0, function is found above the asymptote, so y would be greater than the value of the asymptote. Likewise here, y would be greater than the value of the asymptote. Likewise here, if we know the asymptote, y would be greater than the value of the asymptote, and likewise here, y would be greater than the value of the asymptote for our range. But for domain, since we have arrows on either end, unrestricted functions means that the functions will exist everywhere for your values of x. So x is an element of real numbers for those functions. Okay, guys, domain and range very important, and please do not confuse the domain and the range of these functions with the domain and the range of the hyperbola. Clearly distinct how we write those domain and ranges.